M48 Patent. The M48 Patent is an American first-generation main battle tank MBT introduced in February 1952, being designated as the 9th gun tank M48. It was designed as a replacement for the M26 Pershing, M4 Sherman variants and M46 Pattons used in the Korean War, and as the successor to the M47 Patton. Nearly 12,000 M48s were built, mainly by Chrysler and American Locomotive Company, from 1952 to 1961. The M48 underwent many design modifications and improvements during its production life. This led to a wide variety of suspension systems, cupola styles, power packs, fenders, and other details among individual tanks. The early designs, up to the M48 A2s, were powered by a gasoline engine. The M48 A3 and A5 versions used a diesel engine. However, gasoline engine versions were still in use in the U.S. Army National Guard through 1968 and through 1975 by many West German Army units. Numerous examples of the M48 saw combat use in various Arab-Israeli conflicts and the Vietnam War. Beginning in 1959, most American M48A1s and A2s were upgraded to the M48A3 model. The M48 Patent series saw widespread service with the United States and NATO until it was superseded by the M60 tank, as well as being widely exported. The tank's hull also developed a wide variety of prototypical, utility and support vehicles such as armored recovery vehicles and bridge layers. Some M48 A5 models served into the mid-1980s with U.S. Army National Guard units, and M48 A3s were used as targets for weapons and radar testing into the mid-1990s. Many M48s remain in service in other countries, though most of these have been highly modified and had their firepower, mobility, and protection upgraded to increase their combat effectiveness on the modern battlefield. As of 2015, Turkey is the largest operator with over 750 units in service. Taiwan is second with approximately 500 upgraded variants, and Greece is third with 390 in service. History. After the conclusion of World War II, the United States Ordnance Tank Automotive Command (OTAC) drastically slowed or canceled many tank development and design programs. On 7 November 1950, the Ordnance Technical Committee mandated a change in the nomenclature for tanks in the U.S. military. It was decided that weight designations light, medium, heavy were no longer applicable due to changes in the way tanks were developed and employed on the battlefield, and the varying calibers of main guns now available. Thus, the caliber of the gun replaced its weight designation. For example, the M103 heavy tank was redesignated as the 120 gun tank M103, and the light tank M41 Walker Bulldog as the 76 gun tank M41 Walker Bulldog. The M47 Patton entered production in 1951 and was used by the United States Army and Marine Corps, but ongoing technical and production problems kept it from serving in the Korean War. This forced the U.S. to field older tank models, such as the M26 Pershing and M46 Pattern. In response, the Army launched several design projects for a replacement of the M46 and M26. The United States entered a period of frenzied activity during the crisis atmosphere of the Korean War, when America seemed to lag behind the Soviet Union in terms of tank quality and quantity. Testing and development cycles occurred simultaneously, with production to ensure speedy delivery of new tanks. Such rapid production caused problems, but the importance given to rapidly equipping combat units with new tanks precluded detailed testing and evaluation prior to its quantity production. 31 notable among these were the T-42, 69 and T-48 projects, as well as continuing to pursue further improvements to the M47. General Bruce C. Clark stated, "We know exactly what we want. We want a fast, highly mobile, fully armored, lightweight vehicle. It must be able to swim, cross any terrain, and climb 30-degree hills. It must be air transportable. It must have a simple but powerful engine, requiring little or no maintenance. The operating range should be several hundred miles. We would also like it to be invisible." 11. T-48 project. The T-48 was to focus on improving the turret design of the M47 Patton and using a more powerful gasoline engine with better fuel economy. 1/4 and 1/8 scale design mock-ups of the turret were constructed during May 1950 using the Tone 119 9mm main gun of the M47 Patton. The design study was accepted by the Army in December, and a contract for the advanced production design and engineering APE of a 9mm armed tank, the T-48, was awarded to the Chrysler Defense. 6 prototypes were built, the first by December 1951. 11. The hull was redesigned, moving the driver's station to the front center, and the bow-mounted machine gun and its associated crew station were removed and converted to safe container storage for additional main gun ammunition. The front glacis was redesigned into a slope and offered much better ballistic protection than former welded and rather flat designs. The driver steered the vehicle using an aircraft-style steering wheel. Initially, the power pack consisted of the Continental AV1795B gasoline engine producing 704 brake horsepower coupled to an Allison CD854, a cross-drive transmission with 2 forward and 1 reverse ranges. The hull armor was increased to 4 in 100 mm on the front glacis of rolled homogeneous steel. It had 6 road wheel pairs per side and 5 return rollers, a torsion bar suspension system, using the T97 ETWO steel track assembly. A new hemispherically shaped turret was implemented for the T-48. This was to eliminate the noted shot traps in the M47's turret design and also lowered the vehicle's height in comparison to the M46 and M47. T-48 Pilot -1 was constructed by Chrysler Engineering to begin the design development at the ATAC Detroit Arsenal Test Center in December 1951. On 27 February 1951, shortly after the outbreak of the Korean War, the Ordnance Technical Committee Minutes Outcome #33791 initiated the simultaneous production and design refinement of the new tank, designating the production tanks as the 9mm gun tank M48. The Army planned to produce some 9,000 M48s within 3 years of development. Such rapid, mass production would close the imbalance between Soviet and American tank forces. Meeting this goal, however, required production simultaneous with operational testing and development. Chrysler Corporation became the principal producer of the tank. Expected production and teething troubles led to the creation of integrating committees to coordinate tank and component development. These Army Combat Vehicle ARCOV committees included military and industrial representatives who provided early warning of defects and recommended remedies. 21-22 testing trials of the T-48 tanks began in February 1952 and continued until the end of 1955. However, the perceived immediate threat of Soviet aggression in Western Europe and the ongoing Korean War impelled Army senior leadership to rush the T-48 tank into series production before the inevitable bugs could be worked out of the new tank design. Instead, It was decided that any needed design changes uncovered by the continued testing and evaluation of the T-48 tanks at the Autoloader Detroit Arsenal Test Center would be incorporated into the M48 series production vehicles as quickly as possible. 2127 T-48 Pilot -1 was designed and constructed by Chrysler Engineering to begin the APE design development at the Autoloader Detroit Arsenal Test Center in December 1951. This tank was provisionally armed with the M36/119 gun using a Y-shaped deflector and a muzzle brake. This gun was not used for production M48 tanks. It used the model hull and turret designs with smaller diametered crew hatches. The driver's hatch incorporated a mechanism that dropped his 3 periscope heads to provide clearance for the hatch door as it swung to the right, and the driver then had to reposition the periscopes by hand once the hatch was closed again. It had 5 return rollers, 6 road wheel pairs per side with the drive sprocket at the rear, and a torsion bar suspension system. Pilot -2 was built in February 1952 and also used the early mod, a design with small hatches. It was fitted with the Tone 139/M41 9mm gun replacing the muzzle brake with a cylindrical blast deflector. A T-shaped deflector was used for production M48 tanks. This vehicle had 2 coaxial machine guns installed, a vertical M1919 FR and a fiftical M2 HV. The full-image stereoscopic T46 Eon/M12 rangefinder was placed in the central section of the turret. Pilot -3 was constructed in November 1952 and used the Mod B hull and turret designs with a simplified, larger diametered hatch that was easier for the driver to operate. Also, the front vision block was removable and allowed for the future use of IR vision blocks by the driver. It also had 5 return rollers, 6 road wheel pairs per side with the drive sprocket at the rear, and a torsion bar suspension system. The Mod B turret also had larger hatches for the commander and loader. An additional 3 hulls were constructed T-48 Pilots 4 through 6 in 1953. These tanks were used into 1955 for the component development of the M48 ATWO production tanks, including fire control systems, turret cupolas, suspension configurations, and power packs. At least one of these hulls was fitted with experimental silica's glass composite armor panels. Components. Armor. In conjunction with the development of the T-48 project, there was some discussion regarding armor. The weight of conventional armored steel needed to provide protection against the emerging large-calibered high-velocity main guns and improved APT's kinetic energy penetrators was making its continued use impractical. Composite applique armor panels made with fused silica glass was envisioned to be fitted to the hull. It was also desired that a turret be constructed using this special armor. The Autoloader and Carnegie Institute of Technology began development of the armor in November 1952 at Fort Belvoir, VA, as Project TT-782/51. This composite armor provides protection against heat, HEP, and heat rounds. Its overall slow development limited its use to the T-48 and was dropped from consideration in the M48 by 1953. However, its development was continued with the T-95 medium tank until 1958. There were 2 different hulls used for the M48 series. The M48 hull had a wedge-shaped front glacis compared to the M46's rather flat design. Early model hulls had smaller diameter driver's hatches. The suspension consisted of 6 road wheel pairs per side with a torsion bar suspension system and 5 return rollers. The engine exhaust vents were located on the top of the rear deck. There was a dual compensating idler arm at the front and dual auxiliary track tension wheels behind the last road wheels. using the T97 ETWO track assembly. The drive sprocket was located at the rear of the hull. Shock absorbers were mounted at the first two and last road wheel arms. This hull design was manufactured for the original M48 and M48 Aeon versions of the M48 series. Many Mod B hull designs used for the M48 Aeon T48 Pilot -3 were further upgraded to the ATWO hull design standard, but retained their original 5-return roller configuration. The M48 ATWO hull design saw several modifications, including a reduction from 5 to 3 return rollers per side. The suspension system was simplified, a more compact power pack compartment, and additional fuel cells with large louvered grille access doors replaced the complicated grillework of the rear engine decks of the M48/M48 Aeon hull designs. This hull was used on newly constructed M48 ATWO and M48A3 tanks of the M48 series. The turret used for the M48 series was hemispherical in shape and was made from cast homogeneous steel. It had a flat gun shield and a standard pop-up styled hatch for the commander and an additional hatch for the loader's station. Early production models of the turret had somewhat smaller diametered hatches. The gunner was provided with an M37 30 cal machine gun with 5,900 rounds of ammunition. Rangefinders and fire control systems. During WW II and the Korean War, most tanks used a direct sighting system where the gun sights and rangefinders were slaved directly to the gun's barrel, but its long-range accuracy depended upon the focusing abilities of the individual gunner. There are two basic types of optical rangefinders, stereoscopic and coincidence. In a stereoscopic model, range determination occurred by measuring the distance from the observer to a target using the observer's capability of binocular vision. The coincidence rangefinder uses a single eyepiece. Light from the target enters the rangefinder through two windows located at either end of the instrument. The Arcov emphasis upon increased long-range accuracy led to the incorporation of a fire control system FCS in the M48. The fire control system included a rangefinder, mechanical ballistic computer, ballistic drive, and gunner's sight. Collectively, these mechanical devices resembled in miniature the fire control systems used in naval gunnery. Only after the Second World War did such systems become small enough for use in combat vehicles. These mechanical fire control systems permitted tanks to engage effectively at much longer ranges than in World War II, a critical consideration for the Army, expecting to enter the European battlefield outnumbered. Instead of a gunner's sight being slaved to the gun tube, the ballistic computer and drive computed the range and elevated the gun. The gunner's primary responsibility lay in keeping the sight on the target. The mechanical ballistic computer made a more accurate computation of range possible by mathematically accounting for such factors as vehicle cant and ammunition type. One too many developmental range finders based on pulses of IR light, such as the optical tracking, acquisition and ranging opter rangefinder of the T95 continued into 1957. 174. Autoloader Systems. Another requirement of the T48 project was to explore the use of autoloaders for the main gun as they became available. Preliminary experiments with a loading system using the T48 turret were unsuccessful due to the limited space and the need to line up the breech with the loading system after each firing. It also was dropped from consideration for use on the M48, but was further developed on the 69 tank as the 90 mm Tone 178 gun. It was fitted with an 8-round autoloader system mounted in an oscillating turret. 90 mm main gun. Arcov also involved the Ordnance Department with the goal of improving the 90 mm gun and its ammunition. The Army expected difficulties in engagements with the Soviet IS-3 heavy tank. 12 work was performed to address this by developing the improved T-300 F-53 heat ammunition and the T-137 series of hypervelocity armor-piercing discarding Sabot HVAP-DS or simply APTS ammunition for the M36 gun. The new APTS round could penetrate 1 in 280 mm of homogeneous steel armor angled at 30 degrees at a distance of 1000 yd 910 m, but was not accepted for service. 12 instead, it was decided to use an improved version of the 90 mm gun, the T-139 for the M48 production tanks. It allowed for easier barrel changing and weighed less than the preceding M36/T-119 gun. It was later standardized as the 90mm gun M41, February 1951. Turret cupolas. The T-48 and M48 mod tanks featured a remote controllable machine gun mount as the tank commander's weapon on a pedestal, which allowed him to fire the 50 caliber 12.7 M2 HV machine gun from within the vehicle's turret. It used a 100-round ammunition box and could also be employed manually by the commander. However, servicing and reloading of the weapon required the tank commander to open his roof hatch and expose his head and upper torso. This remote controllable mount was designated as the 50 caliber machine gun mount, MON, and designed by Chrysler Defense Engineering. By October 1954, the Army decided to amend the design of the tank by installing a cupola. During the production of M48s, it was modified several times, resulting in a wide mix of cupola styles among individual tanks. Afterwards, it was renamed as the Cupola Tank Commander's Caliber 50 Machine Gun MON. 23. The new tank commander cupola would allow the tank commander to aim and fire his weapon while remaining under armor protection via a remote-controlled M2 HV machine gun. However, the commander had to open the cupola hatch and expose his head to reload or service the machine gun due to the limited headroom. These cupolas had a small rearward opening hatch and a single, non-removable vision block. They were designed by Aircraft Armaments Incorporated. Because of its smaller turret roof hatch opening, those MON cupolas retrofitted to early production M48 mod turrets used an adapter ring. The MON Eon cupola design used a G305 cupola riser with 9 non-removable vision blocks installed. Some versions had 7 with the 2 rear blocks deleted between the turret roof and the cupola. It also came with a new bulged hatch cover to provide the tank commander with more headroom and allowed him to reload the weapon while remaining under armor protection. A major drawback of both these cupolas was their inability to mount either daylight or infrared vision devices. The receiver of the M2 HV took up a great deal of space in the already cramped cupola's interior. Also due to restraints in the cupola, smaller 50-round ammunition boxes were used. Development of its eventual replacement, the T9/M19 cupola of the ex-M60 tank, was continued into 1958, and some M19 cupolas were retrofitted to M48 AFIVs to allow for the use of IR and daylight periscopes by the commander. M48. Chrysler began building the new Newark tank plant in Newark, Delaware in March 1951 to produce the M48, while Chrysler Defense Engineering and Arcove continued advanced production engineering APE to evolve the design using the T-48 prototypes at the Autoloader Detroit arsenal. In May 1952, Chrysler came to an agreement to take control on a government-owned and contractor-operated GOCO basis of the Newark tank plant production facility with the U.S. government, and to continue production design refinement of the T-48 at the Autoloader Detroit arsenal. To meet the urgent need for tanks, production contracts were also awarded to General Motors Fisher Body Division Grand Blunt Tank Plant and Ford Motor Company Livonia Tank Plant to produce the tank in Michigan starting in April 1952. Also in July 1952, the Army awarded American Locomotive Company a $200 million contract to start producing the tank in 1953 at the Schenectady Tank Plant in New York. All four companies were given initial production contracts in that same year for around 400 tanks each. The first Chrysler production tank was unveiled on 1 July 1952 as the 9M gun tank M48 and christened the M48 Patton by Mrs. Beatrice Eyre Patton, widow of the late General George S. Patton. The M48 featured a gasoline-powered engine. Different models were used depending on availability and manufacturer. Originally, the M48 mod that was built by Chrysler Defense at the Autoloader Test Center T48 Pilot -1 in 1951 used the Continental AV 1795B coupled to a General Motors CD854, a cross-drive transmission as used for the M47. The M48s built by American Locomotive used a Continental AV 1795C gasoline engine and either an Allison CD854 or 4B cross-drive transmission. Additionally, a two-cylinder gasoline air-cooled engine, sometimes referred to as the Little Joe by tank crews, was provided to power a 28-volt, 300-ampere generator when the main engine was not needed. Fuel capacity was 200 US gal 760 L, providing a cruising range of about 70 mi 110 km. The suspension consisted of 6 road wheel pairs with a torsion bar suspension system and 5 return rollers. There was a dual compensating idler arm at the front and dual auxiliary track tension wheels behind the last road wheels, using the T97 ETWO track assembly, as were the previous M46 and M47 tanks. It had hydraulic shock absorbers mounted on the first, second, and sixth road wheel pairs opposite of the M46 and M47. The bow-mounted machine gun and its related crew station was eliminated, thus providing more ammunition storage for the main gun. The driver's station was moved to the front center of the hull. The steering controls were redesigned. A large aircraft-style steering wheel replacing the wobble stick control of the M46 and M47 and placing the transmission range selector on the floor to the driver's right. Model hulls had a small oval overhead hatch for the driver. T48 pilots -1 and 2 incorporated a mechanism that dropped the 3 periscope heads to provide clearance for the hatch door as it swung to the right, and the driver then had to reposition the periscopes by hand once the hatch was closed again. The vehicle did not have an NBC protection system for the crew and a fording depth of approximately 1.2 m3. 9 ft. It had a crew of 4. The commander, gunner, and loader were positioned in the turret, and the driver stationed in the front center of the hull. The M48's turret consisted of a redesigned flat gun shield and standard pop-up hatch for the commander's station. The M48 mono turret design had smaller roof hatches for both the commander and loader. A 50 cal M2 HV using a Moen remote control mount on a pedestal was available for the commander. When not in use, the machine gun mount could be stowed on a bracket welded to the turret roof in front of the loader. The M48's direct fire control system consisted of an M12/T41 stereoscopic rangefinder with a field of view of 5 degrees and magnification of x7.5, an azimuth indicator, an M20 gunner's periscope, and a T13 super elevation actuator. 2 main bearings are bolted to the mounting plate on the roof of the tank turret to support the range finder on steel radial ball bearings. A parallel gun linkage between the gun trunnion and the rangefinder assures that the line of sight of the rangefinder reproduces the exact motion of the gun in elevation. 60A 30 caliber M1919 FR machine gun was coaxially mounted to the main gun's right and was operated by the gunner. An M12 full-field optical rangefinder was used, the same as the M47. The tank was not fitted with any night fighting or computerized fire control systems. Some early production M48s used a Y-shaped blast deflector on the barrel and carried 53 rounds. 8 ready rounds were stored in the left side of the turret bustle for the loader. The rest were stored inside safe containers in the hull. Tank crews complained that the Y-shaped fume extractor was found to be prone to snagging brush. It was replaced with a T-shaped model early in production. These early M48 tanks suffered from engine, transmission, track, and suspension problems. The first production vehicles suffered from excessive oil consumption and engine failures after only 1,000 mi 1,600 km. The gasoline engine managed only 33 mpg US 0.14 km/L, limiting range to 75 miles 121 km. The M12/T41 rangefinder was too fragile and often broke. Army Field Forces AFF found these tanks to be unsuitable for combat use in Europe and was regulated to limited use by U.S. Army can-use units till numerous shortcomings were corrected. Furthermore, some 120 hulls were found to have insufficient hull armor protection. These were denoted as the M48C and relegated by the Continental Army Command Canark for non-ballistic training use by the Armor School at Fort Knox to train crew members and maintenance personnel. M48A1. The Army concluded in January 1952 that the T-42 had failed as a tank capable of combat in Europe against Soviet tanks and reached the same conclusion in November 1953 for the M48 MATA versions. 32 The M48 AON focused on improving the engine and the vehicle's operational range and fixing numerous mechanical problems. To cope with the lack of range, an add-on modification allowed the use of 4 external jettisonable 55 US gal 210L fuel drums of Mogas motor gasoline that was mounted to the rear deck. This proved very unpopular with tank crews, and operational range remained unsatisfactory. Further ARCOV changes included a desire for the commander to observe and operate his weapons station while remaining under armor protection. At this same time, the U.S. Army Field Forces AFF declared the T-42 medium tank unfit for production in November 1952, mainly due to serious shortcomings of its hull design. Ford's production of the M48 ended in August 1953, after a fire destroyed most of the Livonia tank plant. Testing and feedback from ARCOV had uncovered the fact that the original driver's hatch design of the M48 MATA hulls designed T-48 pilots' -1 and 2 tanks proved to be too small and made for an uncomfortable seating position for the driver when operating the tank with his hatch in the open position. To rectify this problem, a new larger driver hatch was devised that was introduced into series production vehicles as early as possible. Also, the driver's front vision block was removable and could be replaced with an infrared IR vision block. A redesigned power pack featured an AV 1797B gasoline engine and CD 854B transmission. The turret was fitted with the Mohn cupola that enclosed the M2HV machine gun. Cupolas fitted on those tanks with early production MATA turrets used an adapter ring. In April 1953, the Army standardized this configuration as the 9mm gun tank M48 AON Patton and originally applied this designation to both the early MATA hull design and the Mod B hulls currently in series production. Between April 1952 and December 1954, nearly 7,000 M48s and M48A1s were produced, with production contracts for an additional 2,500 tanks to be built through 1956. Army units in Europe immediately received 2120 of these early M48A1 tanks, but correction of Arcov defects discovered after production delayed the fielding of the remaining tanks. The Marines Corps, however, continued to use the M47 Patton. The M48A1's width proved too wide for many European tunnels, complicating rail transport. Operational readiness rates of M48-equipped units tended to be low. The tanks continued experiencing engine, transmission, track, and suspension problems, and the M12 stereoscopic rangefinder was uncomfortable to operate. However, the M48A1 was considered an even match for its Soviet counterpart, the T-54, and fielded to combat units in Europe. On 25 October 1954, the Army decided to amend its designation of the M48 tank. Thereafter, the tanks with the original Mod A hull design and the Chrysler-designed Mohn remote control machine gun mount attached to the tank commander's pop-up hatch would remain the 9mm gun tank M48. However, all those tanks with the Mod B hull, some production M48A1 tanks had the Mod B turret and fitted with the new small turreted Mohn cupola armed with a 50 caliber M2 HV machine gun, would be designated as the 9mm gun tank M48A1. M48A1 tanks with 5 return rollers and the Mod B driver's hatch were modified to the M48 ATWO hull configuration. The hull's armor framing for the engine compartment was modified. In addition, detachable headlights, armored boxes around the taillights, newly redesigned mudguards, an updated fuel delivery system, and a tank infantry phone were added. M48 ATWO. The concurrent testing of the T-48 and production of the M48 was the source of widespread debate among congressional budget oversight committees. The Bureau of the Budget believed that the Army was not progressing with sufficient speed in its tank modernization program and recommended the immediate replacement of the M48 ATWO as well as better quality control. Under the Arcov's single, efficient producer model, Defense Secretary Charles Irwin Wilson directed the Army to reduce the number of contractors producing each model of tank. In a new round of production bids for the M48 ATWO, General Motors underbid Chrysler, and in September 1953, Army Secretary Robert T. Stevens awarded GM Fisher Body Division a $200 million contract to become the sole producer of the M48 ATWO and started production at its Grand Blanc tank plant in Michigan in April 1953. The decision raised skepticism among lawmakers. Senator Estes Kefauver noted the move would effectively leave GM, the only producer of light the M41 Walker Bulldog, and medium tanks when the Chrysler production contract for M48A1 production was set to expire in April 1956. Months later, Chrysler underbid GM in the new round of bidding. In September 1954, the Army awarded Chrysler an exclusive $160.6 million contract to restart production. In November 1955, the Army awarded American Locomotive Company a $73 million contract to begin producing 600 M48 ATWOs the next year at the Schenectady Tank Plant, New York. However, Alco opted to wrap up its tank business when its contract ended in July 1956. In May, the Army awarded Chrysler, the only bidder, a $119 million contract to continue production of the M48 ATWO at the Delaware Tank Plant. In December 1955, Chrysler took on orders initially intended for the American Locomotive after Alco opted production cutbacks to its tank program and became the only manufacturer of the tank by the end of 1956. During the Roman III conference in June 1957, it was predicted that the Congress would not approve the procurement of the M48 ATWO after the fiscal year 1959. However, the ongoing T-95 tank program was progressing slowly as its new technologies were being developed. Several ideas were proposed to replace the M48 ATWO. General Bruce C. Clark stated, "We know exactly what we want. We want a fast, highly mobile, fully armored, lightweight vehicle. It must be able to swim, cross any terrain, and climb 30-degree hills. It must be air transportable. It must have a simple but powerful engine, requiring little or no maintenance. The operating range should be several hundred miles. We would also like it to be invisible." Some ideas proposed were to utilize a nuclear fission power plant in the R-32 or a vapor-cycled power plant fueled by hydrocarbons in the Chrysler TV-8 tank. In response to these findings, an eventual replacement for the M48 ATWO was recommended. Arcove and the Deputy Chief of Staff, Logistics D.C. Slog, proposed a tank based on the M48 ATWO featuring improved firepower and a compression ignition engine, and started the design development of the XM60 in September 1957. The engine deck was redesigned with two large louvered doors that replaced the complicated grillwork of the rear engine decks of the M48/M48A1 hull designs. This new rear hull arrangement on the M48 ATWO tank helped in cooling the engine and minimizing the infrared heat signature of the vehicle. 73. The suspension system was simplified. The track tensioner arm was eliminated. Modifications to the idler arm, the addition of bumper springs and friction snubbers, and a relocation of the air cleaner assembly. The number of return rollers was reduced to 3 per side. With the more compact AVI 1798 engine, additional fuel tanks were installed in the engine compartment, increasing fuel capacity to 335 gallons. Many older model M48A1s were rebuilt to this production configuration, but retained their original 5 return rollers per side. 144. The M48 ATWO-C saw improvements for the turret, implementing the Mod B turret design with larger hatches for the commander and loader. The M12 rangefinder was replaced with a full field coincidence model along with an improved turret control system. The M13 Fire Control System FCS consists of the M5 ATWO ballistic drive and mechanical M13A3 gun data computer, which integrated barrel temperature data with an M17 coincidence range finder. The rangefinder is a double-image coincidence image instrument used as the ranging device of the gunner's primary direct sighting and fire control system. The gunner is provided with an M20-day periscope with a magnification of 8 and an M105D-day telescopic sight with a magnification of 8 and a field of view of 7.5 degrees. Range information from the rangefinder is fed into the ballistic computer through a shaft. The ballistic computer is a mechanically driven unit that permits ammunition selection, range correction, and superelevation correction by the gunner. The ballistic drive receives the range input and, through the use of cams and gears, provides superelevation information to the superelevation actuator. The superelevation actuator adds sufficient hydraulic fluid to the elevating mechanism to correctly position the gun. M48 ATWOs were widely deployed to both the U.S. Army and U.S. Marine Corps, fully replacing the M47 Patton in combat units as well as being exported to NATO allies and foreign governments. In 1967, M48 ATWO tanks still in service with National Guard units were upgraded to the A3 configuration. The M48 ATWO hull received modified armored boxing around the taillights, an updated fuel delivery system, and a tank infantry phone type. The gasoline engine was replaced with the AV's 1792A. They remained in canoes training use with the Army National Guard through 1979. M48A3. The continued use of gasoline engines was undesirable due mainly to its high fuel consumption, poor low-end torque, and fuel flammability. Arcov industrial representatives had expressed desires for a diesel engine for the tank since 1953. Continental Motors and ATAC began to develop an experimental X-shaped vapor-cycled engine design powered by hydrocarbons in 1954 for the T-95 tank, but it remained unreliable. In June 1955, ATAC adopted the recommendations and allowed a diesel engine to be used if it significantly contributed to better fuel economy. 31 By August 1956, the diesel-powered AV's 1790 was recommended for the M48, and the Army requested the initial retrofitting of approximately 1020 older M48A1s and A2s with the new engine in December. By February 1957, the U.S. Army had around 600 converted M48A3 Patton tanks, and the U.S. Marine Corps had received 419. The A3 model incorporated a diesel engine which greatly improved its cruising range. Because many M48 A3 tanks were conversions from earlier models, many details varied among individual examples of this type. M48 A3 tanks could have either 3 or 5 support rollers on each side and might have either the early or later type headlight assemblies. Some retained their earlier monoturrets and different cupola styles. During the Hungarian Revolution of 1956, a Soviet T-54, a medium tank, was driven onto the grounds of the UK Embassy in Budapest by the Hungarians. After a brief examination of this tank's armor and 100 mm gun by a British military attaché, the UK decided that their 20-pounder 80 Form L/66-7 was apparently incapable of defeating it. There were also rumors of an even larger 115 mm gun in the works. In response to this, the U.S. Army started development of the XM60 to replace the M48 tank series and incorporating the Arcov recommendation of a more powerful main gun, the 105mm T254. Instead of immediately getting a 105mm main gun, the M48 A3 tanks were to retain their existing M41 9mm main guns due to funding shortfalls that made it impossible to supply enough 105mm main gun rounds for all the planned converted tanks. Secondly, there were still large stockpiles of 90mm main gun rounds on hand. In addition to the conversion of older model M48s, Chrysler continued to build new vehicles. New vehicles built to this standard used the M48 Atwo hull design with 3 return rollers and had redesigned fenders and mudguards, armored boxes around the taillights, among other minor details. They were fitted with another redesigned commander's cupola, the Mon Eon. It had a modified hatch to allow more room in comparison to the previous Mon cupola, and the 2 rear vision blocks were eliminated. The driver's steering wheel was replaced with a T-bar control and received a padded seat. M48 procurement for the Army ceased and M48 Atwo hull production ended in May 1961. The Newark tank plant was closed in October. This newest version of the M48 series received the designation Tank Combat Full-Tracked 9mm Gun M48 A3 on 19 March 1958. 29. The M48 A3 was withdrawn from Europe by October 1961, being replaced with the M60 tank. As U.S. armored and cavalry units rotated out of combat deployments to South Vietnam, most of their M48 A3 tanks were either directly transferred to the South Vietnamese Army or to Thailand. Forcecom withdrew the M48A3 from combat service with both the U.S. Army and U.S. Marine Corps in 1973, replacing them with the M60 Aeon tank. Some M48A3s continued in service with National Guard units until 1979. Some were repurposed as AVs. Afterwards, they were relegated to target use for the testing of radar and weapons systems until the mid-1990s. They were replaced in this role by the QM60, M48A5. The last major U.S. upgrade of the M48 tank series was the M48A5. This conversion upgrade was applied to M48A3 versions still in service with Army National Guard units in order to maintain the training levels of Guard units as well as using a commonality in ammunition amongst tanks. The upgrade featured the mounting of the M68 105mm gun carried in the M116 mount and the all-metric measurement M16 fire control system. The hull was upgraded by applying the M60 Aeon Rise Hull PIP update kit and incorporated as many of the components as possible. Some of these included the retrofit of the AV's 1792C Rise diesel engine incorporating TLAC engine panels coupled to with a CD856 cross-drive transmission, a 300-gallon fuel capacity, and the Tone 142 track assembly, and 13 Aeon NBC protection system for the crew, and the replacement of the 30 caliber M37 coaxial machine gun with the 7.62 NATO M219/Tone 175 machine gun. Because all M48A5 tanks were conversions from earlier models, many characteristics varied among individual examples of this type. M48A5 tanks could have either 3 or 5 support rollers on each side and might have either the early or later type headlight assemblies. Some retained their earlier cupola styles. Starting in 1975, M48A3 tanks that were still in service with the Army National Guard were converted to the M48A5 standard. These tanks were initially converted from former M48A3 tanks using the M48 Aeon hull design with 5 return rollers and given the designation M48A5 PI. But after August 1976, these early hull conversions were further upgraded, the PI designation was removed, and these tanks were redesignated as the M48A5. By March 1978, 708 M48A5 tanks had been converted from the M48 Aeon hull model. In conjunction with the conversion of M48 Aeon tank hulls, the conversion of M48A3s mated to M48 Atwo hulls with 3 return rollers to the M48A5 standard was also implemented in 1976. The conversion program ran from October 1975 to December 1979, with a total of 2069 M48A3s converted to the A5 standard. They were used by Guard units and can use to maintain their training levels and proficiency. In May 1987, at Fort McCoy, 1st Battalion, 632nd Armor Regiment of the Wisconsin Army National Guard retired the last M48 tanks in the U.S. military. The tanks were parked in a holding pen at the WI Mobilization and Training Equipment Site mates and later transferred to the Moroccan Army. They were replaced in National Guard service by the M60A3. However, many other countries continue to use these M48 models. Israel's wartime experiences with their M48/F48C Magach tanks spurred the IDF to implement its own changes. These included replacing the Moan cupola with a low-profile Erden-type cupola that mounted an M60D machine gun for use by the tank commander. A second M60 machine gun was mounted on the turret roof for use by the loader. Internal ammunition stowage for the 105mm main gun was also increased to 54 rounds. Many of them were fitted with Blazer ERA panels. F48 series. M48s for use in foreign military service were designated as the F48 series by the U.S. Foreign Military Sales FMS. These were essentially M48s with minor modifications requested by approved foreign purchasers. Some of the modifications included removal of the Moan cupola, different models of machine guns, electronics, fire control systems or radios, external armor plates, smoke launchers, and power packs. Israel purchased many of these tanks, forming the basis for the Magach series. This series included the following designations: F48, modified M48/M48A1 variant for non-US service. F48A, modified M48 ATWO variant for non-US service. F48B, modified M48A3 variant for non-US service. F48C, modified M48 A5 variant for non-US service. F48 AVLD, modified M48 AVLD variant for non-US service. Combat service. Vietnam. The M48 saw extensive action with the U.S. military during the Vietnam War. Over 600 Pattons would be deployed with U.S. forces during that war. The initial M48s first landed with the U.S. Marine 1st and 3rd Tank Battalions in 1965, with the 5th Marine Tank Battalion later becoming a backup/reinforcement unit. The remaining Pattons deployed to South Vietnam were in 3 U.S. Army battalions, namely the 177th Armor near the DMZ 67 M48 ATWO C-23 tanks supplied from U.S. Army Training Center at Fort Knox, and 44 tanks from Letterkenny Army Depot. Tanks were used by the 77th Armor from August 1968 to January 1969. These were later replaced with M48A3s, the 169th Armor in the Central Highlands of central South Vietnam, and the 234th Armor positioned near the Mekong Delta. Each battalion consisted of approximately 57 tanks. M48s were also used by armored cavalry squadrons in Vietnam until replaced by M551 Sheridan Armored Reconnaissance Airborne Assault Vehicles ARAV in the divisional cavalry squadrons. M48A3 tanks remained in service with the 11th Armored Cavalry Regiment until the unit was withdrawn from the conflict. The M67 Aeon flame tank, nicknamed the Zippo, was an M48 variant used in Vietnam. From 1965 to 1968, 120 U.S. M48A3 tanks were written off. The M48 Patton has the distinction of playing a unique role in an event that was destined to radically alter the conduct of armored warfare. When U.S. forces commenced redeployment operations, many of the M48A3 Pattons were turned over to the Army of the Republic of Vietnam ARVN forces, in particular creating the battalion-sized ARVN 20th Tank Regiment, which supplemented their M41 Walker Bulldog units. During the North Vietnamese Army NVA Easter Offensive in 1972, tank clashes between NVA T-54/PT-76 and ARVN M48/M41 units became commonplace. But on 23 April 1972, tankers of the 20th Tank Regiment were attacked by an NVA infantry tank team, which was equipped with the new 9M14M Malyutka NATO designation Sagar wire-guided anti-tank missile. During this battle, one M48A3 Patton tank and one Moan 113 Armored Cavalry Assault Vehicle ACAV were destroyed, becoming the first losses to the Sagar missile, losses that would echo on an even larger scale a year later during the Yom Kippur War in the Middle East in 1973. By 2 May, 20th Tank Regiment had lost all of their tanks to enemy fire. 212 during the first month of the First Battle of Quang Tri. All ARVN M48 Pattons were lost. 52. The M48s performed admirably in Vietnam in the infantry support role. However, There were few actual tank versus tank battles. One was between the U.S. 169th Armor and PT-76 light amphibious tanks of the NVA 202nd Armored Regiment at Ben Het Camp in March 1969. The M48s provided adequate protection for its crew from small arms, mines, and rocket-propelled grenades. South Vietnamese M48s and M41s fought in the 1975 spring offensive. In several incidents, the ARVN successfully defeated NVA T-34 and T-55 tanks and even slowed the North's offensive. However, due to shortages of fuel and munitions faced by the South Vietnamese military because of the U.S. Congress placed ban on the further funding and supply of military equipment and logistics to the country, the American-made tanks soon ran out of ammunition and fuel and were quickly abandoned to the NVA, which then put them in their service after the war ended in May 1975. In total, 250 of the ARVN's M48A3s were destroyed and captured, 10 and those captured at least 30 were only used briefly before being phased out and turned into war memorial displays all over Vietnam. M48s, along with Australian 20-pounder 80-form-gunned 113 Centurions of the 1st Armoured Regiment, were the only vehicles in use by the anti-communist side in the Vietnam War that could reasonably protect their crews from land mines. They were often used for minesweeping operations along Highway 19 in the Central Highlands, a two-lane paved road between An Khe and Pleiku. Daily convoys moved both ways along Highway 19. These convoys were held up each morning while the road was swept for mines. At that time, minesweeping was done by soldiers walking slowly over the dirt shoulders of the highway with handheld mine detectors. During this slow process, convoys would build up into a dangerously inviting target for the enemy, especially their guerrillas and partisans. As a result, a faster method was improvised, the Thunder Run, in which one M48 lined up on each side of the road, with one track on the dirt shoulder and the other track on the asphalt, and then with all guns firing, 80 they raced to a designated position miles away. If the M48s made it without striking a mine, the road was clear and the convoys could proceed. In most cases, an M48 that struck a land mine in these operations only lost a road wheel or two in the explosion. Supply of M48A3 tanks to South Vietnam. 1971-54. May 1972, 120. 135. October 1972, 72. 135. November 1972, 59. 218. January 1973, July 1974, 16. Total, at least 321 M48 tanks. According to official U.S. data, 343 M48s were delivered to the ARVN up to March 1975. The United States lost at least 123 M48 tanks non-repairable during the war. A result, the United States with South Vietnam lost about 500 M48 tanks. Indo-Pakistani Wars. M47s and M48s were used in tank warfare by the Pakistan Army against the Indian Army's Soviet T-55s, British Centurions and US M4 Sherman tanks in both the Indo-Pakistani War of 1965 as well as the following war in 1971, with at least some good results. During Operation Grand Slam, Pakistani tank forces, composed mainly of M47 and M48 Patton tanks, thrust through the Indian defense lines very quickly and swiftly defeated back Indian Army armored counter-attacks. The Pakistanis used approximately a division's worth of tanks in the operation, although not all were Pattons, with upgraded Shermans included as well. In contrast, Pakistan's Patton tank failed to live up to its high expectations in the Battle of Azal Uttar in September 1965, where about 97 Pakistani tanks were lost, the majority of them being Patton's M47s and M48s. Later, the Patton tank was the main Pakistani tank at the Battle of Chawanda, and its performance at that battle was deemed satisfactory against Indian armor. The Patton was later used by Pakistan again, this time in the Indo-Pakistani War of 1971. A counter-attack led by the 13th Lancers and the 31st Cavalry Army units was defeated by the Indian 54th Division around Battle of Barapind in December 1971. The Pakistan Army Patton tanks could not stop an assault by Indian T-55 Soviet-supplied tanks of the 2nd Armored Brigade. At least 9 of the Pattons were destroyed by T-55 tanks during the Battle of Nainakat. 342 in total. More than 80 Pakistani Pattons were knocked out during battle, mainly by Centurion and T-55 fire. India later set up a temporary war memorial, so named Patton Nagar or Patton City in Kemkaran district in Punjab, where the captured Pakistani Patton tanks were displayed for a short period of time before being scrapped or sent all across India for use as war monuments and military memorials. Analyzing their overall performance in their wars with India, the Pakistani military held that the Patton was held in reasonably high esteem by both sides and that combat tactics were to blame for their utter defeat and the following debacle at Azal Uttar. However, a post-war U.S. study of the tank battles in South Asia concluded that the Patton's armor could, in fact, be penetrated by the 20-pounder tank gun 84 of the Centurion, later replaced by the even more successful L7 105 gun on the Mk7 version, which India also possessed, as well as the 75 tank gun of the AMX-13 light tank. Middle East. M48s were also used with mixed results during the Six-Day War of 1967. On the Sinai battlefront, Israeli M48s outgunned with the then advanced 105 L7 rifle tank gun were used with considerable success against Egyptian IS-3s, T-54s/T-55s, T-34/85s, and Su-100s supplied by the Soviet Union during the 1950s and the 1960s, such as during the Second Battle of Abu Ajala. On the Sinai front, Israel lost 50 M48 tanks of 117, 39 M48 ATWO, and 11 M48A3. However, on the West Bank war front, Jordanian M48s. Jordan was also a user of the M48 Patton, as was Israel at the same time period, were often defeated by Israeli 105 armed Centurions and WW2-era upgraded M4 Shermans M51s outgunned with French-built 105 tank guns, not to be confused with the British L7 105 tank gun. In purely technical terms, the Pattons were far superior to the much older Shermans, with shots at more than 1,000 meters simply glancing off the M48's armor. However, the 105 main gun of the Israeli Shermans fired a heat round designed to defeat the Soviet T-62 tank, which was the USSR response to the M48's successor in U.S. service, the M60 Patton. The Jordanian Patton's general failure on the West Bank could also be attributed to excellent Israeli air superiority. The Israeli army captured about 100 Jordanian M48 and M48A1 tanks and pressed them into service in their own units after the war, as were the Jordanian 113 APC they seized during the war. Israel used 445 M48 tanks in 1973 during the Yom Kippur War. From 15 to 18 October, M48 tanks participated in the largest tank battle of the war, Battle of the Chinese Farm. The battle involved the Egyptian 21st Armored Division 136 T-55s, 25th Armored Brigade 75 T-62s, Tank Battalion 21 T-55s from 24th Armored Brigade in the total 232 Egyptian tanks, and the Israeli 143rd and 162nd Armored Divisions about 440 tanks. The battle ended with an Israeli victory, but both sides lost a huge number of tanks in this battle. Each side lost about 200 tanks. On the night of 15/16 October, the Israeli 14th Brigade of the 143rd Division lost 70 tanks out of 97. Between the 16th at 900 and the 17th at 1400, the Israeli 143rd and 162nd Divisions have lost 96 tanks. As of 18 October, the Egyptian 21st Armored Division had no more than 40 tanks remaining of an original 136 tanks available at the start of the battle. 64, 25th Armored Brigade had only 10 tanks of an original 75 T-62s. Aside from the Israel Defense Forces IDF, the M48 was also operated by the Lebanese Army, the Christian Lebanese Forces Militia, the Druze Progressive Socialist Party's People's Liberation Army Militia, and the Shia Mal Militia. All the tanks seized by the militias were captured from the Army's mostly Shia 4th Brigade, which collapsed due to sectarian divisions in 1983. On 10 June 1982, 8 Israeli M48 A3s, 2 M60 and at least 3 M113 APC were lost in a successful ambush by Syrian T-55 tanks and BMP-1 infantry fighting vehicles, IFV, during the Battle of Sultan Yaqub in 1982. The Lebanese army still operates about 100 M48s. In 2007, during the 2007 North Lebanon conflict, Lebanese Army M48s shelled militant outposts located in a refugee camp. Together with the M47, M48 tanks were used by the Turkish armed forces during the Turkish invasion of Cyprus in 1974. The Turkish armed forces in northern Cyprus continue to use M48 tanks today. When the Kurdish-Turkish conflict began, the Turkish armed forces had a number of M48s. These were used throughout the 1980s and the 1990s as static artillery and was used in defending military base perimeters from enemy attacks. Iranian M48 tanks were used widely in the Iran-Iraq War from 1980 to 1988, where they faced Iraqi T-55s, T-62s and T-72s, alongside M60 Pattons, in fierce and harsh combat with their Iraqi foes, with mixed results. M48s of the 37th Armored Brigade were used in the Battle of Abadan. About 150 of M48s were lost in this tank battle alone. 362. Africa. In 1973, Morocco took delivery of its first M48 A3s. By the end of the 1970s, further deliveries of M48 A5 had occurred, and the upgrade to M48 A5 was achieved locally with the aid of U.S. consultants. In 1987, a final shipment of 100 M48 A5 tanks from the Wisconsin National Guard was delivered to the Moroccan Army. There are unconfirmed reports of deliveries of Israeli M48 A5s during the 1980s. The tanks were used in the Western Sahara Desert against Polisario guerrillas. Pakistan used M48 Pattons while reinforcing American troops during the Battle of Mogadishu in 1993. 324. Variants. T-48. Developmental prototypes designed in 1950 and used between 1951 and 1955. M48. Initial production variant with mono-hull and turret designs featuring M41 9mm gun, MON remote controllable machine gun mount, and AV 1795 or 7 gasoline engine. Deemed not fit for combat use in Europe, relegated to canoes use only. M48C M48 with incorrect hull ballistic protection, relegated by Cunard to the Armored Forces School at Fort Knox for non-ballistic training of crew members and maintenance personnel. M48A1, first variant to have Moen cupola and Mod B hull design, fitted with external fuel drums to extend its range. M48 A2 redesigned hull with simplified suspension system and louvered engine access doors, AVI 1798 fuel-injected gasoline engine, and Mod B turret design. M48 A2C M48 A2 fitted with M13 fire control system. M48A3 featured ABS 1792 a diesel engine and Moen Eon cupola. Withdrawn from combat use in 1973, replaced by M60 Aeon. M48 AFIR, proof of concept prototype, mating the T95 EFIR turret to the M48 ATWO hull. M48 AFIV PI, early conversions of M48 Aeon hulls to the M48 AFIV standard. Retained the ABS 1792 engine, CD 855 a transmission, and T97 track. All were further upgraded in 1976 with components from the M60 Aeon Rise hull PIP update kit and redesignated M48 AFIV. M48 AFIV featured M68 105mm gun, all metric measurement M16 FCS, Koch's machine gun upgraded to M219, and a crew NBC protection system. Hull component upgrades included AVS 1792C Rise engine, TLAC engine panels, and Tone 142 track. Some were fitted with the M19 cupola. All were relegated to the Army National Guard for canoes training use, replaced by the M60 A3. M48, M48 A3 designation for target vehicles, withdrawn from use by 1994 and replaced in role by QM60. Specialized M48 AVLD, armored vehicle launched bridge former M48 A3 with 60-foot 18 meters scissors bridge mated to the M48 Aeon/M48 ATWO hull. Most were upgraded with the M60 hull PIP update kit. M48 Tagesh AVLD, Israeli variant of the M48 AVLD. Former Jordanian M48 ATWOs. Upgraded with Merkava-based track and suspension, upgraded engine, and 2 TZ-Med tandem bridge sections. M67 flamethrower tank Zippo, an M48 tank armed with a flamethrower and a mock barrel and deflector, named after a popular cigarette lighter. M48 Minenram Panzerkehler, German mine flail variant based on the M48 ATWO hull with upgraded 986 German MTU 871 CAF 101 diesel engine and Renk HSWL 284M transmission. As of 2007 they were still in service. M48 Marksman SPOG self-propelled anti-aircraft gun, British short-range marksman anti-aircraft system designed by GEC Marconi. Armed with 2 Oerlikon 35mm cannon mated to M48 ATWO hull. Not accepted for U.S. service. M247 Sergeant York DeVad Division Air Defense, a short-range air defense system designed by Ford Aerospace armed with 2 Bofors Fortum cannons mounted on the M48 Aeon hull incorporating component upgrades from the M60 Aeon hull PIP kit. Cancelled by 1985. M48 T5 Tame, Turkish combat support vehicles based on the M48 ATWO hull designed by TLFC Kayseri and introduced at the IDF show at Ankara, Turkey in December 2005. M48 T5 ARV Armored Recovery Vehicle, The turret has been replaced with a welded armored superstructure that provides protection from shell fragments and small arms fire and a front-mounted stabilizer/dozer blade. It is fitted with a hydraulically operated winch with a maximum rated capacity of 70 tons and an auxiliary winch with a capacity of 2 tons. Both winches are located at the front of the vehicle. M48 T5 CEV Combat Engineer Vehicle. The boom is mounted on the right side of the hull at the front, but has an extendable jib that can be fitted with various attachments to meet specific engineer requirements. When used as a crane, it has a lift capacity of 7 tons. The boom can be traversed through 195 degrees. Additional equipment. Mate bulldozer kit for the M48 tank series SNLG 278. The mate bulldozer installed on the M48 series tank will increase the vehicle's weight by 4.45 tons 4 metric tons. It is controlled by the driver. International. F48 series, foreign military sales designation for the M48 series. F48, modified M48/M48A1 variant for non-US service. F48A, modified M48 ATWO variant for non-US service. F48B, modified M48A3 variant for non-US service. F48C, modified M48 A5 variant for non-US service. F48 AVLD, modified M48 AVLD variant for non-US service. Israeli variants. Many of the Israeli M48s have been upgraded with additional reactive or passive armor. These up-armored versions are referred to as the Magach series. Magach 1, Israeli M48A1/F48 variant armed with M41 90 main gun. Different configurations exist. Magach 2, Israeli M48 ATWO/F48, a variant armed with M41 main guns, some fitted with ERA and Erden cupola. Different configurations exist. Magach 3, modernized Israeli M48 AON/ATWO/A3, armed with British 105 L7 AON cannon, Erden low-profile commander's cupola, new communication suite, and an ABS 1792 750 HP diesel engine. Most were eventually fitted with Blazer ERA. Different configurations exist. Magach 5, generally similar to the Magach 3, but with upgraded ABS 1792D engine and CD 856 a transmission. Most were fitted with Blazer ERA and Erden cupola. Different configurations exist. Spanish variants. M48A3E, M48A3/F48B variant with M68 EON 105 main gun, 17 bone C rangefinder, 13 AFIR ballistic computer, and /VSS 1 Vone IR searchlight. M48 AFIV EON, M48 AFIV E with upgraded engine. M48 AFIV ATWO, Hughes in K7 fire control system with laser rangefinder and solid-state ballistic computer and passive night vision equipment. M48 AFIV E3 prototype vehicle. M48 AFIV ATWO fitted with gunner's IR thermal sight and a new gun stabilization system. South Korean variants. M48 A3K, South Korean modified M48 A3/F48C fitted with laser tank fire control system LTFCS. M48 AFIV cone 105 MK M68 AON main gun, digital fire control system, Moen cupola and steel side skirts. M48 AFIV K2, same as cone but fitted with Erden low-profile cupola. M48 AFIV KW, same as K2, but without side skirt armor. Taiwanese variants. M48 A3 Taiwan variant, M48/F48B variant with lower fuel capacity, operational range lowered to 194 miles 312 km. M48H/CM11 Brave Tiger, M48/M60 hybrid variant mating the M48A3 turret to the M60A1 rise hull. Included improved gun stabilization and new fire control system. CM12 M48A3/F48B variant upgraded with CM11 FCS and weapons systems. Lower fuel capacity, range 126 miles 203 km. Turkish variants. M48 A5 tone, Turkish M48 A5/F48C variant. Modifications include M68 EON 105mm gun and 19 FCS, a passive night vision system, and AVD's 1792C Rise diesel engine. Some fitted with M19 cupola. M48 A5 T2, upgraded to M21 FCS, laser range finder and TTS thermal sight for the gunner. West German variants. As a member of NATO, West Germany acquired a large fleet of M48 tanks. Kampfpanzer M48 ATWO CG Aeon, West German M48 ATWO/F48 armed with 9mm M41 main gun with a cylindrical blast deflector. Kampfpanzer M48 ATWO G ATWO, West German upgrade mounting M68 105mm cannon and MG3 coaxial machine gun, along with the MTU 871 diesel engine. Some were fitted with the Mate bulldozer kit. M48 A5 MOLF modular laser fire Greek M48 A5/F48C variant fitted with MS-18 fire control system. Zulfikar 1 Iranian modernized M48A3/A5 variant developed in the mid-1990s, armed with a Russian Tu-46 125mm smoothbore main gun. Super M48, West German modular update offered in 1994 by Cross Maffei and Wegmann and other partners for the M48 ATWO/A3. Upgrades included applique armor panels for the turret, NBC protection system, MOLF 48 fire control, laser rangefinder, upgraded engine and transmission. Armed with L7A3 105mm gun. Only 5 prototypes built. Operators. Current operators. Greece 390 M48 A5 MOLF. Germany 20 Meinram Panzer Kaler in service as of 2007. Iran 180 M48 A5. Lebanon 104 M48 A5. Morocco 225 M48 A5. Poland 4 Meinram Panzer Kaler, transferred from Germany. South Korea around 300 M48 A3K and 500 M48 A5 Cone/K2 are in service. M48 A3K are expected to be replaced by the K2 Black Panther in the distant future. Most of the M48 A3K are used in reserve, but the South Korean military continues to use a few tanks in active service. However, the South Korean M48 A3KS are being replaced with K1 tanks. Taiwan 450 cm11, 100 cm12. Thailand 105 M48 A5 PI. Turkey 758 M48 A5 T2 in service. All other variants 2250 pieces including the 1389 M48 A5 tone are phased out of active service. Former operators. Belgium only M48 ALBs. Iraq limited ad hoc use of captured Iranian tanks during Iran-Iraq War. Any remaining tanks scrapped after the war. It was never officially in Iraqi service. Israel 561 Magach 5 Golan. Jordan 200 M48 Aeon. Norway 38 M48 AFIV. Pakistan 300 M48 AFIVs in active service till 2002, currently in reserve. Portugal 86 M48 AFIV received supplied by West Germany from 1977. replaced by 93 U.S.-supplied M60A3 TTS from 1993 and 37 Leopard 2A6s in the 2000s. North Vietnam, limited ad hoc use of captured U.S. and SVA tanks during the Vietnam War. It was never officially in service with the Socialist Republic of Vietnam. Many are displayed as war memorials. South Vietnam few hundred. Spain, 164 M48 A5E. Tunisia, 28. West Germany active service through 1993. United States of America. Non-state former operators. Lebanese forces, 7 M48 A5s captured in 1984 from the Lebanese Army and returned in 1991. 63-64. People's Liberation Army, 7 M48 A5s captured in 1984 from the Lebanese Army and returned in 1991. 59.